Alright, so for this section, you'll need to find this page titled Simplifying a Square Root. That's what we'll be working on today. So here's the thing, before we simplify square roots, let's just once again look at what a square root is. So we're all doing exponents this chapter. So if I take a square, so 3 squared, what that means is 3 times 3, and that equals 9, right? 3 squared is 9. So going backwards, the opposite of that would be square root. That sign means square root. So if I take the answer, if I take the square root of 9, that equals 3. If 3 squared is 9, then the square root of 9 is 3. Alright, and so what that basically means is, because 9 comes from 3 times 3, and that's how we got it here, right? 3 times 3. So the thing about squares, it's not spelled the same, but squares rhymes with pairs. Okay? And so squares are really about pairs. So 9 is a pair of 3s. Alright, think about shoes. You wear a pair of shoes. That means you wear 2 shoes, but it's really only 1 pair. Okay? So if you'll notice, because 9 comes from a pair of 3s, the answer is just 1 3 because it's 1 pair of 3s. Okay? Perfect squares, like 9, it all comes out because the number's a perfect square. Okay? So, once again, if you use your calculator, it'll come out as a whole number, and that's fine. What we're going to do here is to work on problems that are not a perfect square. Okay? So just to kind of prove that, like this problem says the square root of 50. So if I take my calculator, if I type in square root of 50, look what I'm going to get. 7.0, it's this long decimal because I can't do a number times itself to make 50. Okay? Now I can do other numbers to make 50, but a square is a number times itself, right? So here's how we're going to break this down. We're going to simplify it. And just like when you simplify fractions, you're making the number smaller. We're going to simplify the square root by making the number inside the symbol smaller. Okay? So here's how we're going to do that. Okay? So square root of 50 is not a perfect square. We've already seen that. Okay? So if you get a decimal and they want you to simplify it, here's what you have to do. We're going to break it down with multiplication and division. Okay? So how can I make 50? I need to do a number times a number to make 50. Okay? So I can do 5 times 10. That makes 50, right? Now what I'm trying to do is I'm trying to break these numbers down to the smallest possible number. 5 I can't break down anymore because 5 is only 5 times 1, right? So I stop here. But the 10 I can break down more. The 10 I can do 5 times 2. Okay? And then the 5 I can't break down anymore, 2 I can't break down anymore. So here's how you have to look at this. Okay? You're only now looking at the numbers that are like at the end of the road. 5 is at the end, this 5 is at the end, and this 2 is at the end. I'm not looking at 10 anymore. That's not at the end of the road because 10 turned to 5 and 2. Once you have all these pieces, remember what we said of the rhyming word, squares are pairs. So now you're looking for, what do I have a pair of? And I have a pair of 5s. Okay? So, remember up here, the pair came out. In this case, the pair will come out. So, I'm just going to kind of skip this middle box and go down here. Alright, so here's what I like to do. I like to put the symbol first because I'm going to put some stuff on the outside and some stuff's going to stay on the inside. The pairs come out. I have a pair of 5s, but it's only one 5. It's one pair of 5s. What stayed inside? What didn't come out? I couldn't make a pair of 2s, so that 2 stays inside. And so 5 square root of 2 means the same thing as square root of 50, but now it's simplified. I've made it smaller. Okay, if I were to double check this, if I were to put this in my calculator, I'm still going to get that 7.07, whatever the long decimal was. Okay, let me just show you something. It doesn't really matter how you break it down. Okay, like in this case, the way I did it, the pairs happen to be side by side. They don't have to be side by side. Okay, it really doesn't matter. Just to illustrate that point, I'm going to do this the same way. What if I go like this? What if I do 50 as 5 times 10? But now, instead of saying 5 times 2, what if I say 2 times 5? You see, it's a little bit out of order, but look at what's at the end. Even though the 5s are not side by side, it's still a pair of 5s. The 5 will still come out. The 2 will still stay inside. Okay? So, how it is at the end doesn't matter. Just look at all the numbers at the end and make as many pairs as you can. Okay? Alright, so let's try a few practice ones here. Alright, so number 1, we have the square root of 18. That will not be a perfect square. So we're going to break this down. Okay? And once again, there's a couple ways you can do this. I'm going to go 2 times 9. Okay, because I want to get small numbers. 2, that's done. That's a dead end. And then 9 can be 3 times 3. Okay? So now what I'm looking for here are, once again, squares or pairs. So look, at the end I've got 2, 3, and 3. I have a pair of 3s. Okay? So now let's finally simplify this. I'm going to put my square root sign. What's going to come out is a pair of 3s, but it's just 1 3 when it comes out. And then what stays inside is this 2. 3 square root of 2. Okay? Now here's the thing. You might have decided to do it a little bit differently. Once again, with math, you can do things more than one way. So just to illustrate that, I'll try it again. Square root of 18. Some people might think, when you do 18, some people might have said 3 and 6. And that's okay, because that makes 18, right? But the 3 I can't break down anymore. But 6, I can do 2 times 3, right? That's fine. Now I look at my dead ends. I got 3 and 2, 3 at the end. It's like a tree branch at the end, right? And I still have, at the end, 2 makes a pair. I have a pair of 3 still. So the 3 will still come out. This 2 will still stay in. Okay, so it really doesn't matter how you break it down, as long as you break it down all the way and then find your pairs. Okay? Alright, let's take a look here. 8. Well, let's do 8. 4 times 2. And then, what can I break down more? I can break down 4 into 2 times 2. So let's look what we have at the end now. I got a 2, a 2, and a 2. So I want to make a pair of 2s. And it doesn't matter which ones I circle. I can make this a pair. I can make this a pair. It really doesn't matter. Okay? But now when I write my answer, let's put the sign. Let's see what comes out. 1 pair of 2s comes out. So I write the 2 there. What stayed inside? This 2 stayed inside. So the square root of 8 is equal to 2 times square root of 2. Okay? Alright. And let's do one more here. Alright, square root of 27, not a perfect square. So to simplify it, 27 can be 3 times 9, right? And then break it down as much as you can. 3, it's done. But 9 is 3 times 3. Let's get our pairs. So I got a 3, a 3, and a 3. I can make a pair of 3s. So when I write my final answer, a pair of 3s comes out, and this 3 stays in. Okay? Now the last two, it just so happened the outside and inside number were the same. They don't have to. Remember the example in this one. Okay? So it doesn't have to happen. It does happen sometimes. Alright, so here's what I want you to do. Pause the podcast, try these next 3, and then I'll uncover the answers. Okay? Alright, so for numbers 4, 5, and 6, the answers are in purple. Number 4 is 4 square root of 2. Number 5 is 3 square root of 5. And number 6, empty set, there's no answer. Okay? Here's how we got this. Now, number 4 might have tricked you a little bit. Okay? But here's the basic breakdown. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So at the end, I had a 2, a 2, a 2, a 2, and a 2. I had a bunch of 2s. So remember, squares are pairs. I could make 1 pair, and I could make 2 pairs. So this is the first time we've seen that. So when I have 2 pairs come out, think about it like this. Here's what's really happening. This 2 comes out, and because I have 2 2s come out, that's really 2 squared. This means 2 2s. And then I had 1 2 stay inside. So the 2 squared is how I got the 4. Okay? Or you could have thought about it like this. I had a 2 come out, and I had a 2 come out. But the thing is, I can't just put 2 2 because that means 22. When each of these pieces come out, because think about what we're doing here. This is all multiplication and division. So when I put things back together, they get multiplied back together. And so 2 times 2 is 4 on the outside, 2 on the inside. Okay? Number 5, that was kind of straightforward. 3 times 25. 25 is 5 times 5. Whoops. Made a mistake. I put the wrong number on the outside and inside. So sorry. So the 5 comes out and the 3 stays in. Okay? Alright, the reason why number 6 is empty set. Look at what we have inside. It's not just 4, it's negative 4. So 4 is 2 times 2. But because it's a negative, 1 is positive, 1 is negative. Because one's positive and one's negative, I don't have a pair. Okay? So there's no way to simplify it. And I can't do a square root of a negative number. If I put that in my calculator, it'll give me an error. Okay? Alright, so now let's look at how we simplify radicals that now have variables inside of it. Okay, so that's just on this next page right here. So here it says, sometimes you can simplify radical expressions that contain variables. When dealing with square roots, variables must leave radicals in pairs. It still squares as pairs. So let's look at the expression square root of x to the 5th times y to the 4th to understand this. So look, here's a good way to do it. Here's the problem. X to the 5th, y to the 4th. And think about what we've been doing this whole equations chapter. X to the 5th means x 5 times. And then y to the 4th means y 4 times. So it helps. Some people like to write it out with these variables so you can see it. Just like we break down the numbers so you can see it. So now that I have it written out, I'm still figuring out my pairs. So look at these x's. I can make 1 pair, 2 pairs, and that's not enough to make another pair. So that's how I'm going to do my x's. Look at my y's now. I can make 1 pair of y's, and I can make another pair of y's. Okay? So here's what we're going to do. I'm going to jump down here. So here's how we're going to finish the answer up. Okay? I'm going to put my sign so I can just do what's inside and what's outside. So remember, the pairs come out. Okay? So here's how I'm going to do this. I have x's come out. But if I put x, that only means 1 pair came out. But look, I have 2 pairs. So in this case, I'm going to do x squared, because that means x times x. And then this x did not come out, so this one stays inside the radical. Look at my y's now. I had 2 pairs of y's, so when the y comes out, that means 1. How do I make it mean 2 pairs? I put a 2 exponent squared, and there is no y left inside. So this is the final answer. Okay? Alright, so let's try a couple of these together. So here we go. X to the 7th power. So once again, it might help to write out what it means. X to the 7th means x 7 times. So 3, 4, 5, 6, 7. Okay? Now what are we going to do? We're going to make our pairs. Squares are pairs. So we can make 1 pair, 2 pair, 3 pairs. Alright, so let's put our answer. I'll put my radical sign, and let's take what comes out. 3 pairs comes out, so x comes out, but I need an exponent of 3 to show that it's x times x times x. What stays inside? 1x. And that's the answer. Okay? Alright, now let's try this one. Y to the 8th power. So that means I have y, 1, 2, 3, 4, 5, 6, 7, 8 times. So now let's go through and make our pairs. I got 1 pair, 2 pairs, 3 pairs, 4 pairs. So let's put that in the form of our answer. 4 pairs of y's came out, so y comes out, and then there's 4 pairs, so 4 exponent. Now what stays inside? Nothing. Everything came out. So you know what that means is I don't need the sign anymore. If there's nothing inside, I don't need it. Final answer is just y to the 4th. Okay? And if you think about it, it's just like this. Remember the example I showed you? If it's a perfect square, that 3, the sign's gone because it all came out. Okay? So that means that it was like a perfect square. It all simplified. Okay? Alright, so just to give this a try on your own, pause this real quick. Try number 9. And unpause it and check what you get, and then we'll do the bottom together. Okay, so for number 9 here, the final answer on the outside is x times y to the 5th times z to the 7th. In the inside is just x times y. And remember, all these things that are side by side are being multiplied. Okay, that's going to be important here in a minute. Alright, so let's see how we got that answer. Alright, and there were a lot of letters. Okay, so look, if I write all these out, x to the third, one pair comes out, so it's just an x. One x stays in, just an x. 11 y's. So look, I can make 1, 2, 3, 4, 5 pairs. So 5 pairs came out, y to the 5th. This one y stayed in. Z to the 14th. Okay, so I can make 1, 2, 3, 4, 5, 6, 7. So that's why z to the 7th came out, and there's no z's left inside. Okay? Alright, now numbers 10 and 11, 12. So here's the thing with this. I know it's going to look really hard, but it's not. I have a number, and I have variables. Okay, so really all it's doing is it's taking what you did the first page with just simplifying a number inside, and it's taking what you did now, doing variables inside, and just doing them all together. Alright, so once again, if you look at it all at once, it looks hard, so let's just go piece by piece. Alright, so let's tackle the number first here. 8. So remember, I'm breaking that down to make pairs. 8 is 2 times 4. 4 is 2 times 2. Alright, so what I like to start doing is I like to just get my sign so I can start putting the things inside and out. So let's take a look here. I've got 2, 2, and 2. Squares are pairs. So I can make one pair of 2's and 1 2 stays outside or inside. So I'm going to put this pair on the outside, and I'm going to leave some space for my variables, and then this 2 stays inside. Alright, so the number's done. Now let's go to our x. I have 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's see how many pairs of x's we can make. 1, 2, 3, 4. So if 4 pairs of x's came out, x comes out, but it's x to the 4th. And there's one x inside, so that stays inside. And then let's finally go to our y's. I got 4 y's. How many pairs can I make? 1, 2. So y comes out, but it's y squared because it's 2 pairs of y's. No y stays in. That's the answer. Okay? Alright, number 11. Square root of 25 times z to the 10th power. So once again, just do one piece at a time. Let's go to the number. 25 is 5 times 5. So let's get our sign ready for our answer. So what this means is I can't break this down anymore. I got a 5 and a 5. That's a pair of 5's. So what does that mean? That means my 5 comes out for a pair. And there's no number left. So I have no number. 25 is a perfect square. It all came out. Now I've got z to the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many pairs of z's do I have? 1, 2, 3, 4, 5. So that means z to the 5th comes out and there's no z's left inside. So just like we saw up here on number 8, if there's nothing left inside, you don't need that radical sign anymore. Everything simplified, everything came out. Okay? Alright, number 12. So here's what we're going to do here. This problem is a little different. Okay? Now, once again, we got a number inside and we got variables inside, but now we have a number out here already. Okay? So here's what we're going to do. Okay? I'm still going to do like I normally do it. Okay? I'm going to break down the 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Alright? So let's take a look at what we have here. We got a 2, a 2, a 2, and a 3 at the end of our rows, right? I want to make a pair. I got one pair of 2's. This is not a pair. They're not the same. Okay? So here's what we're going to basically do. The 2 is going to come out, right? So I'm going to kind of use the example part. I'm going to put my 2 out. This negative 2 is already here. So remember what this means. When we put things back together, we multiply. So this is going to really mean 2 times negative 2. So when I start writing my answer, Here's my radical sign. On the outside, it's not just negative 2. Now that my pair of 2's came out, it's 2 times negative 2, which is negative 4. Okay? So when we put things together, you're multiplying it together, right? Same thing here. I got a 2 and a 3. I can't put 2, 3. That says 23. So I just put it back together. 2 times 3 was the 6. So the 6 is inside. Okay? Now I've got x to the 5th. So that's 1, 2, 3, 4, 5. By now you can probably do these variables in your head, but that's 2 pairs of x's. So when x comes out, it's x squared. 1x stays in. And then y squared is y. That's 1 pair of y, so it's just y when it comes out. Nothing left inside. Okay? Alright, so tell you what, so that's the introduction to this, okay? And that'll be the end of this video. But the next video, it's going to pretty much be the exact same thing with one extra step, and that's where you're really going to practice. But I'll do a couple examples. So yeah, once you finish this one, you'll hop to the next video.